All right, check your understanding. We're on page 108. So this is page 108. The check your understanding. This is number 3. Immediately, I'm going to rewrite these as a square root. So I have, for a, square root x minus 1 is equal to 4. And first step is to isolate the variable. It is, the radical. Isolate the radical. It's already done. So now I'm going to square both sides. So when I do that, my square and my square root are inverses. I get x minus 1 equals 16. And then solve for x. To do that, I add 1 to both sides. I get x equals 17. And then check. I'm going to check in my original. I have square root 17 minus 1 is equal to 4. That's square root 16 is equal to 4. And 4 equals 4. Check. So you should have gotten x equals 17. The next one for b, I have x plus square root 2x plus 3 is equal to 0. So I'll isolate my radical, subtract x from both sides. That gives me square root 2x plus 3 equals negative x. Remember, equaling a negative variable is okay because x may be negative, and then this will become positive. Now I will square both sides. So I square both sides. I get 2x plus 3 is equal to x squared. And now we have to solve for x. This time we have a quadratic. So I'm going to set equal to 0. So I'll move my 2x and my 3 over. So minus 2x and minus 3. 0 equals x squared minus 2x minus 3. And then we'll see if this will factor. If it won't, we'll have to use the quadratic formula. Is there anything that multiplies to negative 3 and adds to negative 2, which is negative 3 and positive 1? So we'll factor this by grouping. That's x squared minus 3x plus 1x minus 3. Take out the GCF. I get x minus 3. Bring down, there's no GCF, so I'll put a 1. That's x minus 3. And so I get x minus 3 and x plus 1. Apply the zero product property. The zero product property is x minus 3 equals 0, x plus 1 equals 0. So x equals 3, x equals negative 1. Okay, now that I've gotten my 2 possible solutions, I can automatically, guys, at this point, I know that I'm going to have x equals some negative value for this to be true. But let's go ahead and check each. So we're going to check each equation. Check each solution in the original equation. So I have negative 1. So, well, my original was x plus square root 2x plus 3 equals 0. I'll plug in negative 1. So I get negative 1 plus the square root of 2 times negative 1 plus 3 equals 0. So negative 1 plus, that would be negative 2 plus 3 equals 0. So this would be negative 1 plus the square root of 1 equals 0. Negative 1 plus 1 equals 0. Check. All right, I'm going to check my second solution, which is x equals 3. So that would be 3 plus the square root of 2 times 3 plus 3 equals 0. 3 plus the square root of 6 plus 3 equals 0. 3 plus the square root of 9 equals 0. I'm going to stop right there. I can see that this is not true. I knew it was not true right here because at this point in my equation, I had a negative. So I knew that my solution must only be the negative solution. So x equals 3 is called a, what kind of a solution? Extraneous solution. So our only solution is x equals negative 1. All right, number 4. So let's try number 4. Solve the equation 0 equals square root x plus 5, and then use transformations to sketch the graph. Make a connection between graphing it and solving it. All right, so solving it, I'm going to square both sides because the radical is already isolated. So solving, I'm going to start by squaring both sides. I get 0 equals x plus 5. I'll subtract 5 from each side, and I get x equals -5. That tells me, right, that my solution, right, that's where I'm crossing the y-axis, or sorry, the x-axis, I'm crossing at -5, 0. Okay, so now we're going to graph this function, f of x equals the square root of x plus 5, and we'll use the graph of the parent function. First, I'll graph my parent, which is 0, 0, 1, 1, 4, 2. I don't really need to go to 9, but here's my parent. And now I'll identify any transformation. So A is 1, no scale, no reflect. H is -5, right? -5, it's always the opposite of the sign. And then K is 0. So that means that this new graph is shifted to the left 5. So this point moves left 5, this point will move left 5, and this point will move left 5. And here is my transformed function. All right, so it said to solve the equation, then use transformations to sketch. I did. Now make a connection between graphing this and solving the equation. So my solution was at -5, 0, and what you notice is that my graph touches the x-axis at -5, 0. Okay, number 5, it says use your solution to the equation in try these A through B part D, so that would be this guy, to predict where the graph of f of x equals x plus 4 to the 1/2 plus 1 will cross the x-axis. Explain your reasoning. All right, so number 5, recall that this was our equation. We had the f of x equals the square root of x plus 4 plus 1. So this means that I am shifting left 4, and this means I'm shifting up 1. So what will happen to my equation, or sorry, my graph? My graph will be my parent shifted to the left 4 and up 1. So here's my parent. I'll put one more point here, right? Here's the parent. And this parent function is going to shift left 4, I'll do this one in purple, 1, 2, 3, 4, and up 1. Left 4 and up 1. Left 4 and up 1. So my new or transformed function will never cross the x-axis. And it says, and I'm going to say it will never cross because there was no solution. And the last thing I want to do, I'm going to add in a question right here about domain and range. So if we wanted to do the domain of this function, recall from yesterday that my h comma k, which my h is -4 and my k is 1. My h comma k tells me the domain and range of my function. And so for this one, right, my domain will begin at -4 on the x-axis and go on to infinity. And my range will begin at 1 and go on to infinity. And then recall, if we have a reflection across the x-axis, how that would affect your domain and range. So it wouldn't affect your domain necessarily, but it will affect your range. Your range values would both become negative. So it'd be -1, infinity.